In 5.3a, we're going to use a tree diagram to describe chance behavior. In this one, let's talk about the tree diagram. It's when you do a drawing a sequence of sample space to model your chance behavior. Especially when you have a trickier probability, a tree diagram can make a problem incredibly easy. Now in here they want us to refer to this allergy data that we have, and suppose you want to choose two students at random. So what we have on here is a two-way table by gender and by allergies or no allergies. And we want to look at the probability of when we choose two students of the 40 at random if they have allergies or not. So let's do this in the first place for drawing the tree. To start off my tree, I'm going to say that I randomly select a student. Okay. Now, when we randomly select a student, we want to focus on allergies or not. What are the two options of the actual first student in terms of allergies? Well, they either have allergies or they don't have allergies. So what I'm going to write down for this, for the first student, is that allergies, I'm going to call it event A, and I'm going to say no allergies, which is going to be my event N. Keep in mind we're looking about the allergies, so we kind of want to condition on that a little bit. So this is the data that we're talking about for the 40. So the first thing you would do on a tree then is you'd identify the probability for each branch. Now the option is allergies or no allergies. There's no other option. What's the probability someone in this table has allergies? That's going to be 18 out of 40. So that's what I would do here for this first branch, is do 18 out of 40. Therefore, the other one is going to be 22 out of 40 for the other. Now I want to go ahead and pick my second student. So assuming that the first student I chose had allergies, now I pick the second student. What are the options for that second student? Well, the options are the same thing, allergies or no allergies. Well, what if I really had no allergies? What's the option now for the second student? Same thing, allergies or no allergies. So I'm going to use the same letters. Now be thoughtful here. Assuming we've already picked one student from the group of 40, what is now the probability that this student has allergies? Well, assuming this student had allergies, I've taken one from that group of 18, so I'm now only down to 17 students left with allergies, and there's only 39 of them left. What about this one? Well, for no allergies, there's still going to be, in this case, 22 of them having no allergies, but there's still only 39 students left. Looking at this branch, 22 out of 40 of the first one had no allergies. So now, how many have no allergies? Assuming I did have someone with no allergies here, means I know I'm going to have 21 out of 39. This branch here, I never had anyone with allergies before, so there's still going to be the chance of 18 out of 39. So based on that, will that help us answer a probability question? Here it is. Find the probability that both students suffer from allergies. If I look at this tree, there's one branch that shows me both students have allergies. If I follow it, I'm going to see that that branch is this. So what that might help me do is realize I have the first student and the second. Remember, in probability theory, when you hear "and," we're going to have the probability of the first and the second. What I'm going to do is actually multiply these two together. It will give me the actual answer then. If you simplify this, we're going to get 0.196 is the decimal probability. Now, I will tell you, as I get comfortable with probability, for this type of question, I probably don't do a tree diagram, but I like that it's a really good visual. For me, it's almost easier for this problem to say if my first student and my second student, and if I think about it logically, I just compute two different fractions for that. The first student with allergies would be 18 out of 40. The second would be 17 out of 39 because one is already gone. Again, almost easier just to do it this way, but you can clearly see it in the tree diagram here. Now the next thing is called the general multiplication rule. If you were asked to find the probability of A and B, again remember that means intersection or and. If you are not sure if the events are independent, meaning one does not impact the other, one way you can do it is actually find the probability of A and then times it by this, which is called the conditional probability. This is the probability of B given A. So this little straight line in probability theory means given. It's conditional probability. It's basically a subset. Now, this formula written in this format is not on the formula sheet. However, if I were to rewrite it, what I actually could do is divide by P probability of A over here, and you're going to find this formula here actually on the formula sheet. We will do this one in more detail, but what it says here, can you find the probability of A given that B has happened? You can. You do the probability of A and B over the probability of B. Again, we'll reference this in a little bit. Let's talk about this NCAA example though. Here it says about 55% of high school students participate in an athletics team at some level. 5% of these athletes go to college team in the NCAA. Here's the question. What percent of high school students play a sport in high school and they also go and play a sport at the NCAA? Well, one of the things here is they want us to find the probability you played a high school sport and you played at the NCAA sport. So you could use this formula here. How you would write it is like this. You would say the probability of A are here. So this would be the probability of a high school sport, and then you times it by event B over A. So the probability of NCAA given that you played a high school sport. So for this one, do we know the probability you played a high school sport? Absolutely, it's 55%. Do I know the probability I played NCAA sport given that I played a high school sport? That is actually what this percent means here is they said, hey, given I played this high school sport, I went on to college and I played 5% of the time that happens. So this is actually set up for this formula. All you have to do is multiply these two together and get your probability. So what that tells us is that almost 3% of high school students will actually play a sport in college. I want to go a full example using state, plan, do, and conclude on how you would actually use a tree diagram to help you answer a probability question. So here you have media coverage. In 2010, the Kaiser Family Foundation released a study about the influence of media in the lives of young people ages 8 through 18. In this study, 17% of the youth were classified as light media users, 62 were moderate media users, 21 were heavy media users. Of those light media users, 74% described their grades as good, and those were the light users. 68% of the moderate users said theirs were good, and 52% of the heavy users said they were good. According to this study, what percent of young people's ages 8 through 18 describe their grades as actually being good? So this actually can be a complicated question. So the state part of this, what percent of young people get good grades based on this population we're looking at? Okay, here's our plan. And I wouldn't say necessarily write this paragraph down. I'm going to actually show you a tree diagram later. Let's just read this though. If we chose a study or subject in the study at random, the probability of a light user is 17, probability of moderate 0.62, heavy 0.21. Now, the probability you have good grades given your light user is 0.74. The probability of good grades given your moderate user, 0.68, and the probability of good grades given a heavy user, we were told, is 0.52. We want to find the unconditional probability, just the probability of good grades. So I can do a tree diagram for that. So if we start a tree diagram, the best way to do it is I'm going to be a student, right? I come on in and I'm a student in the study. Now, the first thing they're going to ask me is what kind of user are you? You're either light, moderate, or heavy. So I can easily fill in those three branches. You're either light, moderate, or heavy, and those are the green percentages I highlighted here, and I just transferred them to the branches. This totals back to 100%. Okay. Now, if you were a light user, what do we know about you having good grades? Well, it said here 74% of the time you had good grades. So I'm going to come on in here and go down. Means 74% of the time I had good, which means 26 I had a bad, right? Now, moderate, we said 68% had good, so let's just carry that down, which means 32 had bad. And then for the heavy, 52 good means 48 are bad. Now, the thing to notice here is what they've actually done is what these numbers are here. If you read each branch, here's what it says. The probability you pick a student who's a light user and has good grades, or a light user and has bad grades. The and probability means to multiply. So where did they get these values from? If you take 0.17 times 0.74. So this is 0.17 times 0.74. The next one is 0.17 times 0.26 and so forth. All 6 of these branches will add up to 100%. So we have it all clarified. So really, once you have the plan into place, the do part, you just kind of go to the tree and you find your answer. So let's actually do this. What's the probability you pick someone with good grades? Well, of these 6 branches, these are the 3 numbers that represent good grades. So what am I going to do? Well, I'm either going to represent this student or this student or this student. Remember, when I say or in probability theory, it means to add. So I'm going to add all 3 of these up, and I have my answer. So for the do portion, all I'm going to say here, there's 3 groups of students who get good grades. Yeah, I circled them on the previous slide. Those who are light, moderate, and heavy users. They're mutually exclusive groups. You can't be both a moderate and light user, so there's no overlap. So all you have to do is add those probabilities of those 3 groups together. And if we do that, what we're going to find is that we're going to get about 0.66. Remember, this seems basic. Show your work. They want you to get credit for that. Now let's just do our conclusion. So the conclusion, all we have to say, about 66% of the students in the study describe their grades as good.